Hi, my name is Wouter Remmerie and I am the founder of AirShaper. In this video, we'll be looking at glider plane design. This time, we interviewed the people at Friendship Systems, our partner company specialized in variable geometries for flow analysis. They have developed an interactive 3D web application to design a glider plane in your browser. It even includes a first theoretical indication of the aerodynamic properties, after which the model can be sent directly to AirShaper for a full-blown 3D flow analysis.
Hey Jan, good morning.
Hi Wouter, let me introduce myself first. I'm working at Friendship Systems. In Friendship Systems, we came up with the idea of a glider model that would be provided to the customers. So the user just using some sliders, changing the parameters, they are going to be able to have a parametric model of a glider. First, I would like to introduce Cases. Basically, Cases is a platform which includes, and the most powerful part of it is the parametric geometry modeling.
Yes.
And you use the parametric geometry modeling for optimization purposes. Let's say you would like to do a CFD analysis and you would like to investigate your design space. So in order to do that, you have to create a certain model which you will be able, define the model in a very nice way with your parameters so that you would be able to capture most of the design space. So you will be able to investigate through it.
So it's a design space exploration tool that you make very parametric so people can use it without having to spend a lot of time in their own CAD package to define all the possible variations.
Exactly. Within Cases, you can use the feature programming. You're able to define your functions or define the behavior of your geometry, create constraints or whatever. So afterwards comes the connection part where you can perform the connection of your CFD tool in this tab, and afterwards comes the optimization where we do have some optimization methods. Some of them are DOE like Sobol. We also have the Dakota, which is the user can just modify it as he or she wishes.
Yeah. Okay. No, that looks very impressive. And this is for many applications also beyond gliders. This is also for pumps, for example, for other applications.
Exactly, yeah. For ships or for turbo machinery and the glider.
Okay. Okay. No, fantastic. Thanks for the overview. And then you decided to apply this to the topic of glider planes, and we can see one right there. So it would be nice if you could just walk us through the entire process. I thought you had a few different steps you wanted to show us.
Yeah, sure. First, let me tell you that I do start with the wing itself. The user is asked to introduce some inputs, and afterwards, with respect to the parameters, calculate, let's say, mean chord, total area, mean aerodynamic chord, stuff like this. And afterwards, in the final stage, it calculates the neutral point and the CG location of the glider, and all of them are somehow printed within Cases. I would like to introduce the application that is going to be available for the customers. So here we do start with the camber position and thickness. So let's do a first change. I would like to change the camber, and now this data is introduced to Cases. Now the camber is changed, and afterwards comes the phase of the wing. And here you do have like the span length, or the, let's say I introduce a certain parameter, which is a sweep parameter or maximum dihedral parameter. Let's say I would like to change the sweep parameter. Okay, and yeah, you can see that the wing tips just moved because of the sweep during this process. Within Cases, you can always get the, as I told before, the total area of the wing or the mean chord and the mean aerodynamic chord locations, which is in fact quite useful information for the designers of aircraft or gliders.
Yes, yes, indeed. I see it's calculated every time you do an update, so that's nice.
Yeah, and the third time comes for the fuselage, where you can perform some changes. Let's say shape factor 1. Okay, this time it was kind of not very relevant. And for the fourth page, it's for the vertical tail. In fact, from this part, I would like to go to horizontal tail. And in this part, let's say I would like to play with some parameters of the horizontal tail. Let's say the vertical location with respect to my horizontal tail. Okay, here you can see some data added, and for each step, I do some balance calculations for the glider itself. So the designer doesn't have to do all those calculations, which would be quite useful. As a final stage, the user is provided with the gliding angle, and also right now I'm still adding some data, but yeah, for example, I added like the wing cubic loading, and also with respect to my gliding angle, the total range, let's say in theory, the total range that the glider can achieve.
Yes.
So those data can be used in optimization. Let's say I would like to play with my parameters in a way to increase my total range.
Sounds fantastic. These are calculations based on a potential flow, like you mentioned, with an external tool that you use. And then if people go to detail, they can upload this model directly using your STL export function to AirShaper, something that we have tested and tried in the past. And then they can use a full 3D runs-based, with turbulence modeling, runs-based solution based on our platform. That's correct, right?
Yeah, exactly. I mean, the potential flow part is only for the airfoil itself, because for the design, for the initial design, I would need some data because I keep changing my airfoil, but I don't know, let's say, my CL or CD value for the airfoil. And using that, I do some calculations, but in the final stage, of course, I do need a CFD calculation.
Indeed. So your formulas, they are based on potential flow for 2D, which means that you look at slices at the wing profile at different positions of the main wing with the fuselage, interference effects, for example, or wingtip vortices. Things like that are to be done in a 3D flow simulation.
Exactly. And there comes our collaboration.
Indeed. We're very proud to announce this. Speaking of announcing this to the people, we discussed this earlier. When would be the plan to release this functionality?
Yeah, I think in a short time, let's say maybe in a few weeks' time, we are planning to provide this model in the internet. By the way, the users can already reach to some models, some apps on the internet under friendshipsystems.com.
Yes.
And yeah, there are some ship or turbo machine models, and the user just using the sliders can create their own models, and afterwards there is the export button at the very end of the page, which is going to be located here as well. And yeah, afterwards the user will be able to export the model in STEP or STL.
Whatever they need. Okay. No, sounds fantastic. We're looking forward to the release of the product and to make it linked with AirShaper completely, automatically, using the APIs in the future.
Oh yeah, I'm looking forward. I do thank you, and I'm really looking forward for the push button and get the CFD results. Yeah, in collaboration of ours, that would be
Okay, fantastic. We will also share one of the sample reports we already made using your model that we see right now, something similar, so people could get a preview of what to expect once this tool goes live together with the connection with AirShaper. So thanks a lot for the interview, Jehan, and I'm looking forward to speak with you the next time once we have launched the tool and we have the first simulations of the customers coming in.
I do thank you. That would be great.
Okay, fantastic. Have a nice day and talk to you soon then, Jehan.
You as well. Ciao, ciao.
Bye.
So that was it for this video. I hope you liked it. If you have any questions about this new and interesting partnership, just let us know. Or if you're working on your own glider plane design, get in touch and we'll have a look at your project. Thanks a lot for liking, sharing and commenting, and see you soon. Thanks for watching. Bye bye.